In this video, let's get some practice working out the expected shortfall for the case where our random variable is a continuous random variable. Let me assume that I have a position whose daily profit is a continuous random variable which follows the uniform distribution with lower limit as minus 160 and upper limit as 240. The task at hand is to calculate the one-day horizon expected shortfall at 95% confidence. Okay, let's begin. So our profit follows a uniform distribution. What's the PDF, the probability density function for our profit? Very simple. If our profit takes any value which is in between these endpoints, the PDF for our profit will be a constant. If profit takes on any value which is outside these endpoints, the PDF will be equal to 0. Okay? The constant value simply is equal to 1 divided by the distance between the two endpoints, and that is 240 minus of minus 160, and that works out to 400. Okay, so all I'm saying is that this vertical distance is 1 over 400. Okay, if this is the distribution for profit, what's the distribution for losses then? Loss, I know, is equal to minus of profit. If profit follows the uniform distribution, so does the loss. Okay, so loss will also be uniformly distributed, but with endpoints which are left endpoint is equal to minus of the right endpoint for profit, that works out to minus 240. The right endpoint for loss distribution would simply be equal to the negated value of the left endpoint for profit. So that works out to plus 160. Okay, so my loss follows a uniform distribution, and the PDF for my loss is the same as what we had here. It's 1 over 400 if loss takes a value between minus 240 and 160, and PDF is equal to 0 if loss takes a value which is outside these two endpoints. Okay, now that we have our loss distribution with us, let's work out the VAR, value at risk, for a one-day horizon and 95% confidence. For this purpose, very quickly recall the definition of VAR. It's basically that number whose probability of being exceeded equals the level of significance. Since I'm working with a 95% confidence, the level of significance is 5%, which is simply 0.05. Okay, so VAR will be that number on the horizontal axis, somewhere in between minus 240 and 160, such that it creates a right tail whose area equals 0.05. Okay, for this very simple distribution, I can work out the VAR using simple geometry. Let's do this. Let's mark out our right tail. Let this be my right tail. It starts at this value, which is the VAR which I am trying to find. Let the height of this rectangle be 1 over 400. That was my PDF. Let the width of this rectangle be some x. I want the area of this rectangle to be 0.05, and this tells me that x is equal to 20. Okay, because 1 over 400 times x should be 0.05. If x is 20, then VAR, which is this point, should be 160 minus 20, and that's 140. Okay, now I can also work out this VAR slightly in a more rigorous manner, in a more generic manner, if let's say I were to flip around this probability. Let me say that if the probability of loss being greater than VAR is 0.05, the probability of loss being less than VAR should be 0.95. The probability of my random variable being less than a given specified value is actually provided to me by the CDF, the cumulative distribution function of my random variable. Okay, so this probability is simply the CDF of my loss worked out at this value, which is var. I want this CDF to be equal to 0.95. For uniform distribution, recall that CDF is given by the specified value minus the left endpoint, the whole thing divided by the distance between the two endpoints. Okay, equate this to 0.95 and convince yourself that this approach also gives you var equal to 140. Okay, now that we have the var with us, we can now proceed on to calculate the expected shortfall. Recall the definition of expected shortfall. It's simply a conditional expectation of your loss conditional upon loss being greater than var. Okay, this var is worked out at the same level of confidence and using the same horizon as the expected shortfall that we are trying to calculate. Okay, we can very simply and very intuitively work out this conditional expectation to be the expected value of a random variable that takes on values which are greater than var and a random variable whose PDF equals the PDF of our loss divided by the probability of this event happening. The probability of this event is equal to the level of significance, which is 0.05. Okay, so the PDF of the random variable whose expected value will be equal to this expected shortfall in this case would simply be given by 1 over 400, that's the flat PDF for my loss, divided by 0.05, and that gives me a flat PDF of 1 over 20. Okay, so to work out this expected shortfall, I need to work out the expected value of a random variable that takes on values between 140, that's my var, and 160, that's the maximum possible loss, and has a PDF equal to 1 over 20, a flat PDF. Okay, so this random variable, it follows a uniform distribution, and the expected value of this random variable very simply is the midpoint of these two, and it works out to 150. Okay, so my expected shortfall for a 1-day horizon and at 95% confidence works out to be equal to 150. Okay.